Okay, perfect. Okay, welcome to my short presentation about KOMMA, which is an RDF mapper and editing framework for Java. First, we should speak about why we need such frameworks when working in Java or when working with other object-oriented languages. When you look at the difference between Java and RDF, you see that Java is based on an object with attributes. We have one class per object. We have single inheritance, and we also have a static type system. On the other hand, RDF is based on triples. We have statements about objects, multiple types per object. We also have multiple inheritance, and we also have dynamic typing in RDF. And therefore, it is not quite easy to work with an RDF triples and Java API, because you always have to map the logic to a triple-based API and not to a class-based or object-oriented API. KOMMA has a bit of history. It is based on the projects by James Lee, who developed the OpenRDF, Elmo and Alibaba projects. These projects already provided object composition and property mapping for Java. They were based on Sesame, respective RDF4J, and the logic was wrapped in an RDF4J object repository. KOMMA generalizes this idea by introducing an entity manager and combines it with object composition based on the ASM framework and choose. And another influencing component is the Eclipse modeling framework, which is an MOF, an implementation for Java. The Eclipse modeling framework provides a document-oriented API. They call it resource sets with resources for the data. And what distinguishes the Eclipse modeling framework is strong support for adapters and UI components for editing. So KOMMA transfers these ideas to RDF. It's actually a fork of the Eclipse modeling framework, and the resource sets in KOMMA are just named graphs of RDF and not XML documents like in the Eclipse modeling framework. Now I'd like to give you a short overview about KOMMA's components. On the base layer, there's the Eclipse RDF4J framework. It's currently the default framework used by KOMMA, and it provides the interfaces to storage backends. You can think of it like JDBC and SQL for RDF data. On the next layer, there's the data manager. It's simple API for accessing different RDF frameworks. Currently, it's only implemented for RDF4J, but it would be easily possible to also support Jana, for example. Based on those two modules, there is a layer that configures the mapped concepts, behaviors, and also the mapping logic by using a thing that we call KOMMA modules. It's just our unit of configuration. And this layer also provides the type composition framework, which is actually decoupled from RDF and could also be used for other situations where type or object composition is required. Now we have the entity manager. The entity manager is responsible for mapping between Java classes and RDF resources. It's also the single point of access for transactions, for change tracking, and also for caching. Last year, we've also developed a serializer interface. It's like a lightweight entity manager that does one-shot serialization and deserialization of Java objects, and is a lot faster in these use cases if you only need to convert the data once and when you store it, for example, in a JSON document or something like this. Now we have the layer that manages named graphs. It enables you to work with data from multiple sources, for example, from files, URLs, or something like this. And this is the layer that was called resource sets and resources in the Eclipse modeling framework, but here it's called models and model sets in RDF. And the last layer is the editing framework. The editing framework provides headless components for editing, for example, that allow you to propose properties based on ontologies, or that convert between the Manchester-Owl syntax and the RDF representation, or such things. And it also provides UI components for Eclipse-based editors, and this is a legacy of the Eclipse modeling framework, because, as I already said, KOMMA is more or less a fork of those editing components. Now I like to show you the core data model that KOMMA is using. KOMMA has a simple core data model. Every an RDF value is represented by an I-value interface, and we also have references. Those are for blank nodes and URIs, and those references may have a URI or not, and are in this case a blank node, and we also have literals for sure. KOMMA has also a representation for statements and a generalization that we call statement patterns, where some components may be null, for example, for matching the existing statements in an RDF store based on such a pattern. On the other hand, KOMMA has also interfaces for mapped entities. A mapped entity is just called iEntity, and it's an extension of the iReference interface. Such a mapped entity has a direct association to an entity manager. A more specific interface for an entity is the iResource interface. This is an interface that provides you some methods for reflective access to the entity's properties. For example, you can get RDF properties, set RDF properties with generic methods by using the iResource interface. Now we come to the other components of KOMMA. And as I already told you, we have integrated a data manager layer that can be used to plug storage backends in, and it is able to retrieve, add, and remove triples, and currently maps to an RDF for chain repository. And we also rely on the transaction support and the Sparkle facilities. On the right side, you can see a a small excerpt from the iData Manager interface. The hardest part of implementing this interface is the support for the queries. And you have to implement the iData Manager query interface and the iData Manager update interface if you want to integrate your storage backend with KOMMA. The next layer is the KOMMA modules and composition layer. And it actually maps interfaces to RDF types. On the right side, you see a small excerpt of such a mapped interface. This is taken from our examples. It represents a document, and this document has two properties or two attributes, the date of release and the title. And as you can see here, you use the ARI annotation for annotating the type of the interface in RDF, and you use the same annotation for annotating the property URIs or property names. And you can also mix get and setter style with a fluent API. KOMMA supports both, and if you leave out the setters, then the properties are just read-only and you can't change them. Now comes the second part. In most cases, you don't want to just map your interfaces to RDF, but you also want to implement some logic. And this is what KOMMA calls behaviors. And it's actually a legacy of the Elmo and Alibaba projects. For example, KOMMA comes with an interface called iClass, which represents all classes. And this iClass interface could also be read as it's an improved class interface for the basic all class mapping. And this improved interface has a method, for example, has declared properties, where I can ask if this class has some declared properties which are declared by using all restrictions, for example. So we can implement an abstract class called, in this case, class support, that implements this interface. And this abstract class could just implement the has declared properties method and has access to the entity manager by using the method get entity manager. And this behavior also has access to the actually generated bean instance by using the method get behavior delegate, but this is not used in this example. So you can implement the behavior interface for using these methods, but you don't have to use this interface. The behaviors are associated to the interfaces just by implementing them, or you can also use the ARI annotation on the behaviors. Last not least, the concepts, behaviors, and also data types are configured by using an instance of KOMMA module. You can add the concrete interfaces and classes by using those methods shown here on the left. And you also can provide the RDF types here. You can leave out the RDF type, but you can provide it here, so you don't have to use the ARI annotations on the interfaces or classes. You can also So implement custom properties. This is also a new feature that was implemented last year. There you can provide an interface. You can provide an instance of the interface I property mapper that finds properties in your concept classes. So you don't have to use the area annotations, and you can just map your existing interfaces via comma without changing them. You can also register custom literal mappers. For example, if you have a specific data type that should be mapped to a Java object, like an enumeration or another data object, you can just register a literal mapper for this data type, and you have to implement two methods to map to RDF and vice versa. What is also a new feature is a complete custom mapping of objects, where you register an object mapper. This interface I object mapper allows you full control of the mapping process, but you also have to write more logic. You have to implement three methods: the get reference method that gives a blank node or a URI for a Java object, and you have to implement the read and write object methods, and those methods can either get a statement source or a statement sink. There you can pull the statements from or push the statements to. So Comma is quite flexible in the mapping process. It's almost as configurable as Jackson, for example, where you can also configure mappers for your XML or JSON documents, and Comma provides almost the same features. And now we come to the point where the interfaces and the behaviors are composed at runtime. This is a three-step process. First, the RDF type triples are fetched for a reference. Let's assume we got the three types: smart home switch, smart home switchable, and all thing for a specific reference. Now those types are matched to applicable interfaces and classes. For example, we have a Java interface switch and a behavior switch support, and Comma now generates a class or a bean class with one field for each interface and one field for each behavior. That looks like this example. It's simplified and not the real class, but maybe you see how it basically works. So we have an instance of this switch interface, we have an instance of the switch behavior, and we have the methods which are defined on those interfaces, like label and on and a setter for the on property, and those methods of the bean just delegate to the methods of the respective interfaces or behaviors. And if both components, the interface and the behavior, implement a method, for example, because it is annotated with an IRI, an annotation, then those methods are chained. But I don't want to dig too deep in those concepts, so I continue to the next slide. So, but I hope you get a first impression how this composition works in Comma. Now the next layer is the entity manager. Here I want to show some examples how you can query the data actually. You use the manager, create query, it's the same, create queries, Sparkle queries in this example. It's almost the same as with RDF4J or Jenna, but you can use additional methods like set type parameter that allows you to use the array annotations of a class, or you can also, oh, here's a small mistake, bind result types for the resulting for the results of the Sparkle query. For example, we can bind the person interface to the result person. So you make sure that this result is at least of type person, and even if it's a frog or a house or something like this. KOMMA has also facilities for prefetching properties. KOMMA doesn't try to be very smart, so it leaves the prefetching of properties to the user. Usually you would get person instances from such a query here, and each property access of person requires a single Sparkle query. But if you know you will access some properties of the person in the next step, then you could use prefetching. This works by using a construct query where you mark a variable as a comma result, and you also fetch additional properties for this result. For example, we fetch a person here of a specific type, which is encoded in the person class, and we also fetch all other properties of this person. And then KOMMA makes sure that this subgraph that is returned by construct is actually used for constructing a person instance with pre-filled properties. And using the query objects, you can now evaluate the query. You can also pass some binding information here. For example, you want that each result is at least of type person, and now you can just use the person instances here without casting. But you could also leave out the person class here and use a cast to the person interface in this and that line here. Typical methods of the entity manager are shown on the right. You can add statements, you can create instances of interfaces, you can create queries or Sparkle updates, and you also can execute triple level operations like match or remove or something like this. Now we have seen that KOMMA can compose interfaces and behaviors, and based on this we have also a layer that allows to work with named graphs. For example, we have an RDF store with some named graphs. For example, a named graph for the FOV vocabulary and another named graph for describing peoples that imports this FOV vocabulary. And KOMMA helps you with the model set API, where it manages multiple models. For each of those named graphs, one model, and each model is associated with an entity manager that only accesses this model and the all imports closure. And data that is written to the entity manager is only inserted in the corresponding named graphs. And therefore, the model of KOMMA is extended. We have the iObject interface that has an association to a model, and we also have model sets that contain one or more models. And each model set also has a metadata manager, because the models and model sets itself, or also RDF objects, and can be annotated with RDF attributes, and can also query it via Sparkle, for example. This shows a wrap-up of the features for model sets and models. You can load and save RDF files. All imports are automatically resolved. We have also integrated support for change tracking, for undo redo, or for audit trails. We have an ontology-specific association of comma modules with interfaces and behaviors to the RDF types, and you could also implement security for single models by using WebACL. We are, for example, using this in our AnyLink web platform. On the right side, you can see some typical methods of model sets and models. So you can create models, get models. You have the concept of a unit of work that is just an open database connection. We have the data change support and typical methods on the model or node, save. You can add imports or get imports, or also have access to the associated entity manager. This is almost my last slide. As I already said, KOMMA has an extensive editing framework. On the left side is a screenshot of a generic editor that shows the structure of a house in this example. And this generic editor can be customized with adapters for providing labels, for example, for the switch here, or for providing icons and actions. And built-in features are, for example, you can edit those structures in a tree view. You can use drag and drop. You have undo, redo. You have labels and icons, as I already said, and you can integrate the custom actions. Now, maybe, and this is the last question: how do you instantiate the whole stuff? How do you instantiate the entity managers? KOMMA heavily relies on choose for doing this. So you can see choose module on the right side that configures a KOMMA entity manager that is using the RDF-4J framework. So the configure method provides the RDF-4J module. It provides an entity manager factory module and also a cache module for KOMMA's bean and property cache. It also provides a unit of work implementation and the underlying RDF-4J repository. But you can imagine that the RDF-4J module or the cache module can simply be replaced by a Jenner module, for example, or by using another cache module. We are currently using Guava for caching, but you could also use Infinispan or something like this. And using choose also allows you to inject services into your beans just by using the add inject annotation on your bean methods or your behavior fields, for example. Last not least, the usage is simple. You just instantiate your KOMMA module, you configure it with behaviors and the other things, and then you can just create an entity manager factory, in this example for a specific RDF-4J module, and you just use the method get on the factory to get an entity manager instance that should be closed afterwards. Now we come to the examples. KOMMA has some examples that are provided on GitHub in the KOMMA examples repository. This repository contains 4 examples, one for basic object mapping. This is the object mapping example. One for using behaviors. Actually, my colleagues implemented a whole workflow engine that is RDF-based and allows to handle typical processes. We have an example, the smart home example, as I've already shown you, where we show the integration with Eclipse and the editing functions. And we also have a basic integration example for Jackson. And my time is now up. Do we have 5 minutes for a demonstration, Marco?
Yes, please.
So I continue with a short demonstration just to show you where it's really working. I have loaded the example projects into IntelliJ here. The projects are simple Maven-based projects, and they also work as simple Maven-based projects. We also have integrated a smart home launcher that actually launches an IDE. I can launch this IDE by using Maven test. Now an Eclipse instance should pop up here. Yes, it's working. So we can see an Eclipse instance here. That is also that is already preloaded with a perspective provided by KOMMA, the old perspective, and we also have loaded a project into this workspace. It's called Smart Home Example. This contains 2 files: the Smart Home vocabulary and a Smart Home turtle file with example data. I just open the example turtle file, and you see that an editor gets opened. It's the KOMMA's old editor that allows you basic editing of OL and RDFS vocabulary. You can navigate through the files here. For example, if I double click on the smart home import, I go to the smart home turtle file, or I can also navigate to other files that are imported from the web, for example. Let's switch back to the smart home example. As with Protégé or Top Rate Composer, we can also go through the classes. We see here the imported classes in gray, but we could also extend those classes, for example, by a specific room. I can create a specific room here, like a living room class, for example. Or I can also create another one like kitchen. Kitchen, there's already an entity present in the model, so I choose kitchen class for this example. And now I made a mistake and I want to undo this, and you can just use the undo redo logic of KOMMA, and you undo this and you are good to go. The KOMMA has also other views for object properties, data properties that almost work the same as the tree view for the classes. And what may be of interest is we also have an instances view and instances tree. So we can switch through the classes here and see the instances of those classes. We have one house, for example. We have 2 floors and so on. But what is really interesting is if I switch to the instance tree. So I can switch to the house, for example, and I can see the structure of my whole house here. So I can see the house has multiple floors with multiple rooms, and I have switches in those rooms. And the smart home example already contains some logic. So there is a behavior for those switches here. I can trigger this behavior by using the switch action. So if I switch this behavior, you can see that all lamps in this room are switched off, and I can switch those lamps on again. And you see that is all that all is model based and that the labels get updated and also the icons get updated. And you can actually just extend your vocabulary here. So let's say we have lamps and switches, or we want a TV, for example, as an additional device. And now I switch back to my house and I want my TV in the living room. For example, we have a lamp here and switches, but we also have a new child like the TV. I call it my TV. Let's finish it. The TV pops up here. It's of type TV. And now I want one of my switches to also control the TV. So maybe it works. I can just drag and drop it here. Let's see if it works. No, it's not implemented that yet. So let's add it by hand. I want to control the switch, also my TV. So the switch now controls also the TV. And if I use the switch, I see that my TV is switched on. And if I use the switch again, I see that my TV is switched off. So maybe you get an impression how KOMMA is working. KOMMA allows you to create such editors. You can base your editors on many generic components and just extend them a bit. Like it's working actually quite the same as the Eclipse modeling framework. And what is also so interesting, the whole thing also runs on the web. So this shows a hosted RUB workbench. RUB is the remote application platform for Eclipse that allows you to run Eclipse and IDEs in the browser. And you can see here that I can just open, for example, the models. It almost works the same. You can go through the models. Double clicking does not work here, but you can also create classes here. Class 2 is already present, so let's create class 3. You can also undo the creation or redo the creation. And you can imagine that you can also use the same adapters as used here in this web environment. Sorry, in this web environment. So you see the same stuff here. And we also use KOMMA for our web application. It's called AnyLink. It's a platform for RDF data. And let's go into the test model, for example. And here you can also see which classes are defined in the test model. And you can go through the description of those classes. And you can also add something like labels or such things. And this is also based on KOMMA in the end. Okay, that's all for my presentation. And I think we can switch to the discussion, Marco.
Very good, Ken. Thank you very much. I will stop the recording.